Hi, I'll start to present about the Elasticsearch DataFrame in Python. And my name is Jongmin Kim, and I work as developer advocate at Elastic. Let me introduce for myself a little bit more. I started my career as a Java developer, and I'm living in South Korea. And I started my own startup a few years ago, and in that time I met in Elasticsearch, and it just attracted me, and for that I established the South Korean Elasticsearch community group and user group, and for that made me to join Elastic in 2015. So I work as a developer advocate in Elastic community team since then until now. And my Twitter handle is Kim Jaemin, and mostly I work, my playground is Facebook, so there's a link about my personal Facebook page. And Elastic is sponsoring PyCon for whole global for a long time. So, and also Elastic is sponsoring Python communities such like Jungle Girls, and it's really glad to meet you in PyCon, Malaysia. Here's today's agenda. I will introduce Elastic technology a little bit, and I will talk about the Eland. Eland is Elasticsearch data frame, which makes Elasticsearch easier for Python, and I will introduce how Eland data frame works, and I will show a demo about using Elasticsearch in Jupyter Notebook. Here, about the Elasticsearch technology, Elastic technology. Elastic is the company created Elasticsearch. Elasticsearch is a search engine, but Elasticsearch has a capability of aggregating and processing all kinds of data, like not only text, but numeric data and geodata, and it's very fast. And so many companies are using Elastic technology as loggings or business analysis or securities in these days, and for monitorings. And they are using Elasticsearch as a primary data storage, and all the Elastic products are working on top of Elastic Stack, which is based the infrastructure of our solution, and it consists with Kibana, which is our data visualization tool, and Elasticsearch, which is the heart of the Elastic Stack, which stores the data and just searches data. You can query on it. You can use which processor all data works in there. And we have Bits and Logstash, the data ingester. And top of the Elastic Stack, we built all kinds of apps, and these days we categorize into three solutions, which is Elastic Enterprise Search, and Elastic Observability, and Elastic Security. Also, you can download the Elastic Stack on our website, and you can use it for free and open. And also, Elastic is providing SaaS service called the Elastic Cloud, and we have a cloud service on your own. You can install it on your own cloud, which is Elastic Cloud Enterprise, and we also provide Elastic Cloud on Kubernetes. Elastic technology works as a cluster, and it gives most functionality which needed systems these days, such like scale outs, or it provides a REST API, so it can be worked with all kinds of applications in one place. And also, Elastic provides major programming language clients such like Java, Ruby, and Python. And the Python client being provided since a long time ago, which can handle Elasticsearch as a Python objects. But today I want to introduce a more advanced tool which calls Eland. And Eland supports PyPy and CondaForge, which means you can install Eland with a PIP installation tool, or you can install Eland with a Conda installation. Eland is supported from Elasticsearch 7.6 or later version, and its source code is on GitHub. You can find the Eland source code under Elastic's GitHub repository. And also it provides official documentation under eland.readthedocs.io. And here's why you have to use the Eland. Eland provides experience which is very similar with Pandas. Pandas is a very population DataFrame tool which is used at the Python these days a lot. And Eland, you can visualize Elasticsearch data using familiar APIs with the Pandas. And huge data sets can be explored without holding data in memory, because Eland is a connection with your Python client and Elasticsearch, which means your all data stays under in Elasticsearch cluster. So you, when you are using Eland is transferring your query to Elasticsearch and brings back the reply to your Python client. So you do not have to worry about your data staying consuming huge memory. And also Eland provides functionality. You can upload your dataset to the Elasticsearch. So why name is Eland? Eland is elk and moose in Dutch. Elk is the famous name of Elastic because a long time ago when Elastic started, there was a stack with Elasticsearch, Logstash, and Kibana, and lots of people called this elk stack. And elk is the animal similar, looks like a moose or deer. You looks the logo on your right. And also Eland is the name of the Elastic and the data. And also Elastic started in Amsterdam in the very beginning. So there's a name of the street also has a similar name with the Eland in Amsterdam. So and usually when you import the pandas, you use the name of a PD, and we provide to, when you import the Eland, use the name of a ED. Okay, let's talk about the data frames. Eland data frames maintains a query DSL and the post-processing task graphs internally, which means all the hard-working chores are done in backgrounds at the Eland. You do not have to worry about what your application is doing. And it implements a subset of Pandas API, and it maps Elasticsearch query filters and aggregations and the painless scripts to your Python. And all data and operations occurs with Elasticsearch, and all the results are returned into Pandas data structures. So the same, all the Eland is a connector of your Python application and the Elasticsearch, and all heavy works are done by Elasticsearch. Here's how Eland maps Pandas concept data to Elasticsearch. Elasticsearch stores documents, and it has a group of documents called index, and the data frames maps as an index. And each rows are mapped to the documents, and each columns are mapped to the Elasticsearch field. And data frame types are mapping types in Elasticsearch, and like an index or the key store is like a ID or timestamp at the Elasticsearch. And that at the DataFrame, at the Elasticsearch, you can use much more things which Pandas does not provide, such like match query. And match query is a full text query which provides a very basic and most used query in Elasticsearch. And not only match query, not only full text query, you can also use geo queries or all kinds of analyzers. And Elasticsearch is started as a search engine, so it has a functionality of scoring the relevance. So it works the same that with Eland, you can use text scorings and relevance search in your Python applications. And also, it is a pipeline that imports the data or exports the data from Pandas to Elasticsearch. You have a very easy named API that Pandas to Eland and Eland to Pandas, which Pandas to Eland, which creates an index mapping from data types and overrides all specialized types to Elasticsearch, and Eland to Pandas, which brings all data from the Elasticsearch and makes a data frame, and it can convert it to the Pandas data type. And you can pull all data memory, Elasticsearch data into memory, which is not very advised to. So now I will start a Jupyter Notebook demo. So now let's see some demo with a Jupyter Notebook. Here, I'm running a Jupyter Notebook program, and I pre-typed the Eland library and all scripts in here. First, we are loading Eland library and Elasticsearch libraries and all other libraries which we are going to use at our demo. And here's some text which we are going to use later, which prettifies a JSON, because Elasticsearch uses all data type with a JSON, even the query and all the replies. So that's the way we are going to compare how JSON shows in Jupyter Notebook and in Elasticsearch. I'm going to use Elastic Cluster on Elastic Cloud Service. I made a cluster named Conference Demo in here. And you can see here Cloud ID. First, you have to copy this Cloud ID. And you have to put this in here to make an Elasticsearch connection. Also, you can open up the Kibana at the cloud. I'm going to use this Kibana. And at the Kibana, I made a user called the PyCon. And also I made a password in here. You put your username and the password in under HTTP auth. So let's start to run all the libraries. And let's see how Elasticsearch connects. And it shows Elasticsearch cluster information. You can see we are using Elasticsearch cluster version 7.14.1, which is very new. And this information is a very basic information when you try to contact at the REST API to Elasticsearch. Now, Elastic provides, when you starting Elasticsearch, you don't know how it starts, but so at the Kibana, you can load sample data. So we have three types of sample data, which is e-commerce and flight data and the sample web logs. We are going to use e-commerce orders. when you click the add data in here, it loads all sample index from the Elastic demo server, and it creates the dashboard for you, so you can start from the scratch. Let's see, we have a dashboard here, e-commerce revenue dashboard in here. And Elastic has a development tool you can use in Kibana. So here's a Kibana sample data. The name of the sample data is a Kibana sample data. Index is a Kibana sample data e-commerce. So let's see if this data is mapped. And we can use this search API to check documents under here. And we can see we have about the 4,675 documents in this index. So let's copy this index name, and we create the index patterns under our Eland. So Eland data frames, we put here Elasticsearch cluster informations and index pattern information in here. And let's see. So I think we created data frame objects in here. Let's see what we have with the columns. Okay, you can see all kinds of field names in here, which you could check under Elasticsearch. We have field names of category, currency, customer birth date, and geo IP, manufacturer. Or you can check this easily under Discover menu with the Kibana sample data. Here are fields you can check on. Okay, so let's check with the head IP. It brings the top 5 documents, and you see we have 46 field names, which means 46 columns in Pandas, but it shows only few of them. And we can use a shape API, and it shows how many documents, I mean how many rows in this data frame. This is the same number which we had under our whole index documents. So you can view histograms with the testful total price column. Yeah, most of the testful total price value are under 500 and from 0 to I think 250 in here. And we can check information API too. So it brings all column names and all data types in here in Pandas way. We can use JSON, and we can check mappings to similar in Elasticsearch way. So we can view all the mapping informations as a Elasticsearch way, which is exactly the same in here. Mapping. Okay, from here I will uncomment each line, and let's see how it works. At the data frame, we have a field name called the customer gender. Let's see, we have a customer gender at the discover. Yeah, here it is. Customer gender has two types of values, which is male and female. Okay. Now let's use Easyn API, which brings data holds only under customer gender value of a male. So we brought 2,242 rows, which is approximately half of the whole data set. And you can see all the categories name is a men's clothing or the men's accessories. So most customers, most logs which are customer gender field value is a male. Okay. Let's run next line. With this line, we can see we have an API called ESInfo, which shows this information in Elasticsearch way, and it compares with the Pandas data type. So this information shows each fields, each columns is searchable, or is aggregatable, or is a script, which means this columns in this field in Elasticsearch perspective can be searched, or this can be aggregated. This is false because category is a keyword type, but this is true because the currency is the number type. Sorry, but the category is a text type, and the category keyword is a keyword type. So these are kind of differences. And here's the Elasticsearch data type, which shows the field type in Elasticsearch way: text, keyword, date, or we have a geopoint type in here. We have a half float type in here, and it's like a discount amount in Elasticsearch. We define the half float type, but in Pandas, this is defined as a float type, float 64 type. And under the button, it shows the operation task that all these types are filtered as the customer gender is male, which is we queried before. And also we can see post-processing information, which this operation didn't do any post-processing. Now let's run next one. Once we run the tail operation, now we can see some operations under post-processing. Elasticsearch brings top-sized results, basically. But if you want to bring some data at the bottom, you need to do another operations after querying, which is a sort. So Eland did a sort processing because you ran tail operation in Pandas way. So Elastic did a sort operation for you. Okay, let's see next operation. Elasticsearch has an API called aggregation, which can bring the all kinds of aggregated processed values from the numeric field. So we will try to aggregate textful total price field with and let's see how it will be working. So with the textful total price, we brought the median value and mean value, average, and minimum, maximum, and how many values in here, and we have all values sum in here. Of course, you can use describe API, which Pandas provides. So it shows a little bit different. And once you use described without defining field name, it will bring all numeric fields and will display in your screen. And you can use most options like changing size of a histogram, which can Jupyter Notebook do with the Pandas. And next, let's see how we can use Elasticsearch query with the Jupyter Notebook. So Elasticsearch provides a query, and it can be worked with a text field. Let's check under our dashboard first. We have a product name, includes like a black or white or something like that. You can put your query under here. Let's check if how many black products we have. Now, once you put your query on the input form, all dashboards changes with your and it affects in query. Or you can add a filter instead of that. Let's add a filter. Product name, products name, and is black. You can save it, and also dashboards changes affected this query. Let's check query DSL in here, and you can copy it, and you can paste it under ES DataFrame ES query, and you can run ES query in here. So it brings all the data, which includes under products and products name black. You can see it has 2,753 values we brought. Let's check if this is value names are relevant. Okay, let's check products name. Yeah, here's a black. Okay, black. Yeah. Also, you can check. You see that we can use the Elasticsearch query under Jupyter Notebook, like in this way. Also, it provides much complex and high-level queries, such like a geo query. Let's erase this filter, and under here you can see the map. Let's try to geo query at the Elastic dashboard. Let's check in. Let's see. Geo 1. Okay, and I will start a center point in here, and we'll cover around 1,000 kilometer radius. So it will filter all the values in what I drew this round circle in here, and it adds filter on top. So let's edit filter again, and let's copy this query. So you can see the latitude and longitude information in here, in geolocation, and the geodistance in here. Let's copy it, and I will paste it again. Let's see. And this brings the informations, the same informations what we checked in this dashboard. So 1172 documents are filtered. You can use a query and aggregation at the same time. Without query, you can see the sum values and maximum values. And with a geodistance query, we can use aggregation together. So this textful total price metrics and statistics are changed with a query. So you can use usually you can use a query and aggregation at the same time at Elasticsearch, and this Eland gives the same functionality. You can do it at the Jupyter Notebook. Now let's see how we can upload data from Pandas DataFrame to Elasticsearch. I will load your CSV file, which is I downloaded from the government page. It shows the statistics of COVID-19 situations, and it divided from the age. So, and let's see, it have around 600 rows, and it has columns from 0 to 9. This is the age column, 10 to 19, 20s, 30s, 40s, 50s, and so, and over 80. And all the object type is integer, only over 80. I don't know why, but it has a value that float. So I'm going to use the Pandas to Eland API, and I put here the Pandas data frame, which I created over here, and I'll put the Elasticsearch client information, and I'll put the Elasticsearch index name here, and I will define the index mapping. So before running that, let's check we do not make sure we do not have the this COVID KRH index, so index is not found in here. Now let's run this to upload this Pandas to Elasticsearch. So now when you do a search, we can find the informations. We have 596 rows in here, and each documents are indexed nicely. And you can bring up these data frames again and use it to your Jupyter Notebook again. So, and you can bring your index pattern, not only exact name, but you can use the asterisk key as a wildcard. So you can, it brings all index names, starts with the COVID and the dash. So this was the everything I wanted to introduce about the Eland, and how you can use your Elasticsearch data to the Jupyter Notebook with like a Pandas way. And there's much more things that I didn't cover in this talk, such like machine learning and more many things. And I hope on the later you have a chance to meet our great features and solutions again. And hope this talk was helpful for you who are going to use Elasticsearch with Python. Thank you very much.